the file mask and the umask command. This is from the Linux documentation project. The page I'm looking at is File Security. When a new file is saved somewhere, files without permissions don't exist on Linux. The standard file permission is determined by the mask for new file creation. The value of this mask can be displayed using umask command. Umask, enter, and it tells you the umask. Instead of adding the symbolic values to each other, as with chmod, for calculating the permission on a new file, they need to be subtracted from the total possible access rights. Alright, let me explain what this sentence means. When you use chmod and you tell it what mode you want the file to be, it will add the values for that mode to the already existing values. The umask is not like that. Instead of adding, it subtracts. In the example above, however, we see 4 values displayed. Yet there are only 3 permission categories: user, group, and other. The first 0 is part of the special file attributes settings, which will be discussed in section 3.4.2.4 and section 4.1.6. Let me just show you what those sections are about. It's this one, changing user and group ownership, SUID and SGID. It might just as well be that this first 0 is not displayed on your system when entering the umask command, and that you only see 3 numbers representing the default file creation mask. Each Unix-like system has a system function for creating new files, which is called each time a user uses a program that creates new files, for instance, when downloading a file from the internet, when saving a new text document, and so on. This function creates both new files and new directories. Full read, write, and execute permission is granted to everybody when creating a new directory. When creating a new file, this function will grant read and write permission for everybody, but set execute permission to none for all user categories. This before the mask is applied. A directory has permissions 777, a plain file 666. At this point, the umask value is subtracted from these default permissions after the function has created the new file or directory. Thus, a directory will have permissions of 775 by default, a file 664. If the mask value is 002. This is a demonstration in the example below. First, a directory is created, and as you can see, it has 775. Then a file is created, and as you can see, it has 664. This point is covered elsewhere, but I'll just mention it here, in terms of files versus directories. A directory gets more permissions by default. It always has the execute permission. If it wouldn't have that, it would not be accessible. Try this out by chmodding a directory 644. If you log in to another group using the new group command, the mask remains unchanged. Thus, if it's set to 002, files and directories that you create while being in the new group will also be accessible to the other members of that group. You don't have to use chmod. The term that group here refers to your original group. The root user usually has stricter default file creation permissions. See, the root user, his umask is 022, whereas the regular default umask is 002. By the way, there should be an extra 0 up front here. And basically what this does is, instead of 775 and 664, it's going to be 755 and 644. In other words, root even won't let his own group have right to access to files. And this reveals something else, which is that the umask is not even the same for all users. At least it's not the same for the root user as it is for all the rest of the users. These defaults are set system-wide in the shell resource configuration files, for instance etc/rc or etc profile depending on your Linux distribution. You can change them in your own shell configuration file. In other words, the user configuration file for the shell instead of the system one. See Chapter 7 on customizing your shell environment. That's it for this video.